Okay, today's topic is problems based on the capacitors. So I will solve different problems based on the capacitor principles. So what is the capacitor concept first? So any capacitor so what is the capacitor formula is C equal to epsilon A by D. D is the distance between the plates. D is the distance between the plates. Epsilon is permittivity. So that is epsilon naught, epsilon r. So epsilon r is 1 for air. Epsilon r is relative permittivity is 1 for air, different value for different dielectric material. So dielectric material is basically insulator. Then A is the overlapping plate area. Overlapping plate area. Not area between the example. If I take one, these things earlier we discussed when I introduced capacitor. This is one chapati. So this is another chapati. A is not one chapati area. A is not another chapati area. A is this. So when I'm using this A is what? Overlapping plate area. Overlapping plate area. Plate area. Not area between overlapping plates. Not area between overlapping plates. So this is important. Many students will not have this clarity. No confusion in epsilon, no confusion in D, but there is a confusion in A. So everybody says plate area is a common, but if you go into depth of the concept, it is overlapping plate area, not area between overlapping plates. And what is the purpose of capacitor? It is used to store the charge. When charge is stored, voltage will be developing. Accordingly, energy will be developing. So what is energy formula? It is half CV square. What is the basic fundamental formula? V is equal to Q by C. V is voltage across capacitor. Q is charge on the capacitor. C is capacitance. And this concept I explained earlier with the bucket. So this C is like a bucket width. Quantity of water is like a charge. Water level in the bucket is V. So the concept between VQC is similar to this. So C is like a container width. Q is the quantity of water. V is the water level in the bucket. These are the basics. Capacitor store static energy. Energy formula is half CV square. Now we will how capacitor value can be changed. Capacitor value is changed by changing epsilon or by changing overlapping plate area or distance. So these three only useful to change C value. When C is changing, automatically if you fix V, then Q change, or if you maintain Q constant, V will change. So this is the simple concept. So let us see how many ways we can change the value of capacitor. If capacitor is like this, if there is some dielectric material like this, here epsilon R1, here epsilon R2. So terminals AB. And total distance is D, and this distance D1, this distance D2. What is how these two capacitors are connected? Let us say this is C1, this is C2. How they are connected? They are in series. So if they are in series, what is CAB value? Is C1 C2 by C1 plus C2. What is C1? Epsilon R1. A is anyway constant. So that is A by D1 into epsilon R2 A by D2 by epsilon R1 A by D1 plus epsilon R2 A by D2. So like this, you can find the capacitance across A and B. Across A and B. And these two capacitors are connected in series. So how do you connect in parallel? Next connection is parallel. So there is a dielectric constant here epsilon R1, here epsilon R2. These are the terminals A. So what is changing here? This area A1, this area A2. This need not be in the middle, it can be anywhere. And distance remains same. So voltage is same means parallel. Na? So above is C1, below one is C2. So total CAB is equal to C1 plus C2. But what is C1 is epsilon R1. A is A1, but D remains same. Like that C2, epsilon R2, area changing A2 by D remains same. So substitute, you will get the answer. So this first one is series connection. Second one is parallel connection. Parallel. Third one can be series and parallel. How to do it? So here epsilon R1, epsilon R2, epsilon R3. And this is C1, C2, C3. Now C1, C2 parallel or series? C1, C2 parallel. C1, C2 parallel, that is series with the C3. So C1, C2 parallel means C1 plus C2 series with C3 na? C3 by C1 plus C2 plus C3. This is CAB. No, but what is C1 is epsilon R1. What is the area here? This area A1, this area A2. Okay. Epsilon R1, A1, and this distance D1, this distance D2. So epsilon R1, A1 by D1. C2 is epsilon R2, A2, but distance same, D1. What is C3? Epsilon R3, but area remains same, A. So this area is A by D2. So if these numericals are given, we can find out C1, C2, C3 from that CAB. Now, like that series, parallel, series and parallel, we can find out equivalent capacitance. See, any capacitor, one important concept. It has quantity of water Q1, width C1, bucket width C1, water level V1. What is the energy E1 is of C1 V1 square. Now I am increasing the value of C2. If C2 equal to 2C1, if Q2 equal to Q1, if Q2 equal to Q1, if container width is double, when quantity of water remains same, what happens to level? It reduces now V2 equal to V1 by 2. So then what is the energy now? E2 equal to half C2 V2 square. This is half, but what is C2 to C1? What is V2 V1 by 2 square? This is equal to half 2C1 V1 square by 4. So this is nothing but half into half C1 V1 square. So this is E1 by 2. So E2 is equal to E1 by 2. So whenever a container width is increasing by double, when quantity of water remains same, when level is reducing, energy is also reducing. So E1 by 2. So this is the simple relation. If you maintain V constant, then you have to add extra charge. Then in that case, again energy will be different. Or if you in this case Q same, we reduced. Now what is the other case? E2 equal to 2C1. If V2 equal to V1, when V2 equal to V1, when you are adding some more water. So in that case, Q2 is equal to 2Q1. Then what is the energy? Second case, E2 of C2 V2 square. This is of C2 is 2C1, but V2 V1 same only, na, square. What is the case in this case? 2 1 by 2 C1 V1 square. This is nothing but 2E1. So here energy is double, here energy is half. So this is the simple example concept how Q, C, V are connected. When you change C, how energy changing. When you change V, how energy changing, and so on. So these are the basics. This epsilon is like a breakdown. Breakdown means when you keep on applying the voltages, at one stage capacitor will blast. Now from this let us go through the problems now. So all these problems, application of capacitors. Now go through this. Let me go through this. 3 capacitors C1, C2, C3, 10 microfarad 10 volts, 5 microfarad 5 volts, 2 microfarad 2 volts are connected as below. The maximum safe voltage in volts that can be applied across combination and the corresponding total charge in microcoulomb stored in the effective capacitance. So this is the capacitor connection already given, C1, C2, C3, and maximum volt. What is the capacitor specification? As I told earlier, what is the resistor specification? Is P. Capacitor specification is V. Inductor specification is I. This is discussed earlier. So this capacitor can withstand up to 5 volts. C3 can withstand up to 2 volts. C1 can withstand up to 10 volts. Which is having less voltage? C3. If C3 is not breakdown, automatically C2, C1 will be safe. So we should see that C3 is in safe. So what is the formula? VC3, voltage across C3 is nothing but applied voltage VAB, that is dividing between C2 and C3. Voltage division formula. That is nothing but C2 by C2 plus C3. So what is C2? 5 by 5 plus 2. But what is VC3? Maximum voltage is 2. From this, what is VAB? 5 plus 2, 7. 7 into 2, 14. 14 by 5. This is nothing but 2.8 volts. So maximum we can apply voltage across AB is 2.8. If 2.8 is applied, voltage across C3 is 2, voltage across C2 less than 5, voltage across C1 less than 10 anyway. So all 3 capacitors are safe. The maximum safest voltage we can apply across AB is 2.8 volts. Then is also asking total charge. To find total charge, Q2 equal to CT into VAB. But what is C equivalent? C2 C3 series. That means 5 into 2 by 5 plus 2 7 plus 10. VAB is 2.8. 2.8 is nothing but 14 by 5. So simplify 70 plus 10. 80 by 7 into 14 by 5. So 32. 32 micro coulombs. This is the answer. So total C equivalent to simplify VAB 14 by 5. We are getting 32 micro coulombs. So this is one problem. A parallel plate capacitor is partially filled with glass of dielectric constant 4.0 as shown below. The dielectric strength of air and glass are 30 kilovolt per centimeter, 300 kilovolt per centimeter respectively. The maximum voltage in kV which can be applied across the capacitor without any breakdown is. So what is the circuit given already is parallel plate capacitor is partially filled with a glass of dielectric. So this is 4 and this is air anyway. Air dielectric constant 1 and glass dielectric constant is 4. So they are connected like this. And also given, okay, this is the circuit already given in the problem. Next, maximum safest voltage. So which is important here? This is important. Here glass is inserted. This capacitor is anyway safe. Its safety is multiplied by 4. But air capacitor breakdown will not change. So this is AB terminals. Now what is voltage across? I can call it as this is CA. This is CG. So VCA is equal to VAB into CG by CG plus CA. Capacitor with air, capacitor with glass. Glass is the dielectric material. Now, what is the air? Also look at this information. 30 kilovolt per centimeter is the air dielectric strength. And the glass is 300 kV per centimeter. Centimeter means 10 mm. 10 mm is 30 kV kilovolt. And this problem I have done wrong. What is given is different to what I have done. It is given like this. The problem itself this is for this is anyway 1. So total distance this is 10 mm given. This is 5 mm given. This data is given. What is shown in the figure I drawn wrongly, so therefore concept goes differently. So this is A, this is B. Now these capacitors are connected in series, not parallel. So this is already given in the problem. So what else given for A is for A is 1 centimeter means 10 mm is 30 kV. But what is the air gap of this gap is 5 mm. So if it is 5 mm, total 10, glass 5, so air also 5. Is how much? Is 15 kV. Then for glass, 10 mm, what is the breakdown? 300 kV. Here 5 mm is how much? So it will be 150 kV. So glass capacitor breakdown is 150 kV. Air capacitor breakdown is 15 kV. And what is the maximum voltage we can apply so that capacitors will not be breakdown? So which should be say first to A. That means VCA is equal to VAB into CG by CG plus CA. But what is VCA is 15 kV. VAB we have to find. This is nothing but epsilon naught epsilon r. So that will be 4 A anyway common. Distance is total by d by 2 by 4 A d by 2 plus here A by d by 2. So A d by 2 cancel. VAB into 4 by 5. What is VAB from this? 75 by 4. Okay. 75 by 4. So if 75 by 4 kV applied, then there will not be any breakdown in the capacitor. So like this we can answer. I hope you understand this problem. The maximum voltage in kV which can be applied across the capacitor without any breakdown. Glass capacitor anyway it cannot break down, but air capacitor can break down because it is air only. So if that is protected, entire capacitor will be protected. So that's the problem. The parallel plate capacitor shown in figure as movable plates. The capacitor is charged so that energy stored in it is E when the plate separation is D. The capacitor is then isolated electrically and plates are moved such that plate separation becomes 2D. What is the energy stored now? What is the given data? The distance first to D is the capacitor. It is having distance of D. What is the energy it is having? E1. The capacitor is charged so that energy stored in it is E. And the plate separation is D. So that is case 1. Next, what is asking? After it is charged, after it is having energy of E1, it is disconnected from the power supply, electrically isolated, then plates are moved such that plate separation become 2D. When distance is becoming, for example, is D1, what is D2 double na? So 2D1. Then what is C2 value? What is C2 value is C1 by 2. C2 is C1 by 2. Why? E is equal to epsilon A by D. So D double means the capacitor become half. So C2 equal to C1 by 2. When container width is reducing, what will happen to V2? Will be double to V1. So what is energy E2 now? Half C2 V2 square half C1 by 2 to V1 square. To simplify further, half C1 by 2 or V1 square. 2. This is nothing but 2 into half C1 V1 square. So it is 2 into E1. Na? Therefore, E2 is equal to now 2E1. E2 is equal to 2E1. What is the answer is E2 equal to 2E1. Just plate separation is increased. C2 value reduced to half. V2 increase it to double. Then use this formula, simplify, you are getting E2 equal to 2E1. So all these problems I C is changing. When C is changing, either Q or V changing, energy will change. So based on this concept, many problems are coming. A parallel plate air capacitor is shown below as a total charge Q and a breakdown voltage V. A slab dielectric constant 6 is inserted as shown. The maximum breakdown voltage and the charge at this voltage respectively would be. So here epsilon R is 6, here air, and L by 2 means this is inserted in the middle, exactly equal portion. Once again, what is given? A parallel plate air capacitor as shown below as a total charge Q and breakdown voltage V. That means a first capacitor is filled with air only. This is the air capacitor and parallel plate air capacitor as shown below as a total charge Q. The total charge Q and breakdown voltage V. Breakdown voltage V. So they are parallel plate air capacitor. Now a slab dielectric constant 6 is inserted like this. Inserted like this. Look at it. 6 is inside as shown below. So maximum breakdown voltage and the charge at voltage respectively would be charge at this voltage. Now these two capacitors are connected in parallel. When they are in parallel, what is same? V is same. So whatever V it is having, after inserting dielectric also, because they are parallel, V remains same. So V is same only. So V will not change. Next, C equivalent is change. What is CAB or CT equal to CG? These two capacitors are connected in parallel. So CG plus CA. But what is CG epsilon? So it will be 6. Area will be half A by 2 D same plus A by 2 D same. So this is nothing but 6 plus 1, 7. 7. So 7C or otherwise 7 A by 2 by D is the total C equivalent. So C equivalent how much increased? 7 times increased. Now what will happen to charge? Q is equal to CV na. So now Q final Qt equal to CT, V remains same. What is CT? 7 A by 2 by D into V. So this is nothing but 7. This is Q, original 7 by 2. 7 by 2 A by dV. So this is nothing but 3.5. 3.5 is the answer. Because originally Q is equal to CV. What is this C? Epsilon? Air only, na? So epsilon not A by D. That epsilon not everywhere I ignore. So anyway, that will cancel even if you take. That's why A by dV is equal to, this is Q. A by D into V equal to Q. So you will get 3.5. So A bit is the answer. V into 3.5 is asked in IES. So a parallel plate air capacitor as shown below has a total charge Q and a breakdown voltage V. A slab dielectric constant 6 is inserted as shown. The maximum breakdown voltage and the charge at this voltage respectively would be. At this voltage means V. So what is the charge is 3.5. So how I solved this one? They are in parallel. So total C equivalent is CG plus CA, and this CG, a glass dielectric is inserted in a slab. There is some slab, not necessarily a glass. So that is 6. So here 6, here 1. So 7 times. 7 and A by D is the actual capacitor. So 3.5. So capacitor is increased by 3.5, charge also increased by 3.5 because V is same. This concept always important. If V2 equal to V1, if C2 equal to 3.5 C1, then obviously what is Qt or Q2 is 3.5 Q1. So if this is increased 3.5, then only V2 equal to V1 when C2 is increased 3.5 times. That is a concept. Now a parallel plate capacitor filled with two dielectrics as shown in figure below. If the electric field in the region A is 4 kilovolt per centimeter, the electric field in the region B in kilovolt per centimeter is. So there are two regions A and B. One is epsilon r equal to 1, epsilon r equal to 4, a gap of 2 centimeters. Is asking electric field parallel plate capacitor filled with two dielectric as shown. If the electric field in the region A, electric field means E is 4 kilovolt per centimeter. So there is a formula E is equal to V into D. E is the electric field, V is the applied, V is the voltage across, D is the distance. Now, because of this one, these two capacitors are connected in parallel. So V is same, connected in parallel. Na? So if this is A, this is B, if you are thinking. So they are connected in parallel. So V is same and D is also same. V same, D same. E also remains same. Na? E also remains same. So therefore E2 equal to E1. But what is E1 given? 4 kilovolt per centimeter. E2 also 4. So answer is C. Because they are connected in parallel, V remain same. Distance between plates also not changing. So electric field also will not change. This is independent of these dielectric values. All are based on simple principle only. This is again another an air capacitor of a capacitance 0.005 microfarad is connected to a direct voltage of 500 volts, is disconnected and then immersed in an oil with a relative permittivity of 2.5. Find the energy after immersion. So first air capacitor, what is its value? C naught equal to 0.005 microfarads. Is connected to a direct voltage of 500 volts. So it is charged to 500. Then disconnected, immersed in a oil with a relative permittivity of 2.5. Find energy after immersion. So air capacitor is this much. After immersed in the oil, its permittivity 2.5. So capacitor value is increased by 2.5. So 2.5 into this is the new capacitor value. What is the original charge Q naught? V into C naught. What is the V? It charge to 500 volts. C naught is already there. So this much charge it is having. What is V new? So charge remains same. Capacitor value is changed. Na? So voltage also changes. V new equal to Q naught by C new 200 volts. Then what is the energy new? Half into C new. This is I can say E new. C new. V new square. What is C new? 12.5 into 10 power minus 9. V new is 200. What is the answer? 250 microjoules. It is only affect capacitor is changed. Then Q remains same, V changes, C changed, V changed, E also changed. So this is a simple concept. All are similar principle, but so many styles of asking question. This is asked in IES. A parallel plate capacitor consisting of two dielectric material is shown in figure. Two dielectric material, epsilon 1, epsilon 2, epsilon 1 again. So epsilon 1, one dielectric, epsilon 2, another. The middle dielectric slab is placed symmetrically with respect to the plates. If the potential difference between one of the plates and the nearest surface of dielectric interface is 4 volts. If the potential difference between one of the plates and the nearest surface of the dielectric interface is 4 volts, determine epsilon 1 by epsilon 2. Assume parallel plate capacitor as an electrode area of A meter square. A meter square. So what is the voltage applied this side? 10 volts. Epsilon 1, epsilon 2, epsilon 1. It is equal distance from both. So this is d by 2. Total distance is d, and remaining d by 4, d by 4. D by 4, d by 4 become d by 2. In between d by 2. So this is how it is arranged. And at epsilon 1, breakdown is 4 volts. 4 volts. Determine epsilon 1 by epsilon 2. So this equivalent circuit we can draw like this: C1, C2, C1. Epsilon 1, epsilon 2, epsilon 1 again. So C1, C2, C1. What is voltage across C1 is VC1. What is the total voltage applied? 10. VC1 given in the problem 4. But what is VC1 formula? 10 into voltage division formula. C1 C2 by C1 C2 plus C2 C3. 3 is again 1 plus C3 C1. Both are same na, C1 square. So simplify this further. 10 C2 by 2 C1 plus 2 C2 plus C1 will come. 10 into what is C2? Epsilon 2 A by D by 2. D by 2. 2 times of C2 substitute plus C1. Epsilon 1 A by D by 4. So further you simplify, but VC1 given in the problem 4 volts. Simplify, you are getting epsilon 2 by epsilon 1 equal to 4. So like this problem can be solved. This is also another wonderful problem. A differential capacitive sensor with a distance between the extreme plates 100 mm is shown in figure below. So this total distance is 100 mm. The difference voltage delta V, V1 minus V2, where V1 and V2 are the RMS values. So in the circuit shown V1, V2. For a downward displacement of 10 mm. So one of the plate which is in the middle is moving downward. How much distance moving downward? 10 mm. If of the intermediate plate from the central position in volt is. So when center plate is moved down by 10 mm, what is delta V is asking. That is the question. So applied voltage is 10. Total gap is 100. First it is in the middle. So 50-50. When C2 middle plate moving down, then above gap become 60, below gap become 40, because that plate is moving down by 10 mm. So this is reduced to 40. This is increased by 10 now, so 50 become 60. 60 plus 40, 100. When this change is taking place, what is delta V? What is delta V is asked. So first find out V1 and V2, take the difference. So what is V1? 10 into C2 by C1 plus C2. And V2 is 10 into C1 by C1 plus C2. And what is C1? Epsilon A by D. What is D? 60. And other one 40. Like that V2, V1 calculate. Only thing is D is changing. D, when you are taking C2, D is 40. When you are taking C1, D is 60. Like that V1, V2 calculate, take the difference, you are getting 2 volts. Just to go through simple simplification. But that is the principle. It is C equivalent problem. The equivalent capacitance of input loop. Here I1 given, I1 going through 1K, 1K. Here 49 I1. So 49 I1, I1 total added. So 50 I1 will flow here. So what is V1 expression? 1K series is 2K I1 plus 1 by C. What is C? 100 micro. 100 integral. What is the total current? 50 I1 dt. So 51 ja 52. So it will be 1 by 2 integral I1 dt. So what is the C equivalent? 1 by C equivalent integral I1 dt. Na? So this C equivalent is equal to 2 microfarads answer. Find CAB. So it looks like some odd combination. Find CBY, CBY, CBY. So the best technique is take B and Y outside. B and Y outside. Between B and Y, there is one capacitor CC. This is one. Take one more A. Between B and A. This is CC. Between A and Y. A and Y, there is one more capacitor CC. A and Y. There is another. If this is A, this is also A. Na? Between A and Y, CS. A and Y, CS. A and Y, CS. Between B and A, CS. B and A, C, yes. Now we want CBY. CC, CS parallel. CC plus CS. These two parallel, CC plus CS, both are in series. So by 2 parallel with the CC. Simplify, you'll get answer. With just redraw, you will get easily. Don't think these three will form a delta, other will be deltas, converting delta to star, all those things. Wrong approaches. So each capacitor is having 1 coulomb of charge. Find CAB, 1 coulomb. So everywhere 1 coulomb, 1 coulomb, 1 coulomb. What is C1? V equal to Q by C na. So it will be V is equal to Q by C. C is equal to Q by V. What is Q? 1 coulomb. What is V2? So C1 is 1 by 2. What is C2? 1 by 3. What is C3? 1 by 5. What is asking? CAB. So when all are in series, 1 by C equivalent equal to 1 by C1 plus 1 by C2 plus 1 by C3. So 1 by 1 by 2. 1 by 2. 1 by 1 by 3. 1 by 1 by 5. So this is nothing but 2 plus 3 plus 5 is 10. So what is C equivalent now? 1 by 10 is 0.1 farads. Is the answer. So like this. So all these are the problems based on capacitors. So I stop at this point. So all these just to listen the video more and more number of times. All of you subscribe my channel. Please like, share the videos, subscribe to the channel, activate the bell button. You will get all the updates. Wish you all the best.